Observing is where chemistry starts. This is probably the first video you should watch that I put together here. When we hear the word observing, the first thing we think about is seeing, looking at something. The classical fictional detective Sherlock Holmes chastised his sidekick Watson by saying, Watson, you see, but you don't observe. And that is quite significant to me. First of all, observing is not an inference. An inference is a judgment. Many times we are very quick to make inferences about things. We look at a person, we say, oh, that's a smart person, or that's a dumb person, or that's a rich person, or that's sweet, or that's sour, just by looking at it. And very big mistake in chemistry. So we start in observing with the senses. Observation is a sensory experience. And that means one or more of the senses has defined the observation. We should always, when we make our observations, make no value judgments. Many times, students will make a value judgment that this solution, you pour two liquids together and nothing happens. But they forget to listen to them. They're just using their eyes. So make no value judgment. Don't delete checking on sound or perhaps a smell. Get your nose up there and take a look at it through your nose. No value judgments. Of course, one thing in chemistry, this business of taste, beware. Never taste anything unless the instructor tells you you can. And that's not going to be too often. The third thing is that when we make an observation, we have to express a certain degree of uncertainty. Don't say something's 14 inches long. You could, in words, the language, you could say it's about 14 inches long. Or in mathematics terms, which is the most common thing, you could say it's 12.3 inches long. That gives you some value, some degree of uncertainty. It could be plus or minus 1 inch, for instance. Uncertainty is important because the whole idea of an observation coupled with uncertainty is indeed the basic definition of a fact. And many times we put our facts together, and we put enough facts together, we are allowed to make inferences. But remember, the inferences should be based on a set of facts, and they should be tested. You should have a set of facts before you make the inference, and it should be tested over time. Don't make, because something's sweet, don't say right away the inference is, oh, this is good for you, it's good to drink, because it may very quickly turn out to be a disaster. The fourth thing is your observation should be as quantitative as possible. Now, don't say something is long or hot or cold, but put some quantitative character to it, a temperature reading, a a mass reading, a length reading, something of that sort. So learn to do that in the labs. And with that, these 4 and 5 go together. Extend your observations with instruments. There are a variety of instruments you use for volume. You use graduated cylinders, pipettes, burettes, analytical balances, spring balance, simple ones, electronic balances, thermometers. Lots of instruments. Extend them extend your observations. Another thing is to vary your perspective. Don't just look directly at a solution. Look perhaps underneath it, and you may see some precipitate forming. Vary the perspective. It's amazing what you see when you look in and around what you're working with. Vary the perspective. And this perspective can be a time. One of the big things I like is to watch things over time. BOT means behavior over time. In fact, one of my favorite things is to have students draw graphs of behavior over time of a situation. It's simple, maybe simply listing your observations over time or recording particular quantitative values. And I will say one of the final things is to impose change. Now, imposing change, you should wait to the last because you can destroy something. Now, you can have physical change, and that could even destroy something. For instance, you can take a penny and cut it in half, and you'll see the silvery zinc color inside from the zinc. You can't put it back together. But some physical changes, like melting an ice cube, you get your water back. It's the same chemical. But the second thing is chemical, and that's one of the last things you should do, because then you definitely have changed composition. Taking a piece of paper and burning it and see how it goes from the entirely different set of properties. Now, why are we bringing these up? This is something you could start with first and second grade. But here's the deal. As you go along, in everything really, not just in chemistry, have a little checklist like this. Put this together and start applying it in some of the things you do. Pick up anything, and remember, use senses. Listen to a glass of water. You may hear a fizz or maybe some carbonation. Don't be afraid to use all the senses, providing, remember, the taste caveat here. When you make an observation, say it's about. Don't say it's exactly. It's about. For instance, if we observed a rainbow, and we say, "Oh, look, that rainbow appears to go into some building." Well, you're making an observation because you've expressed uncertainty and you used your sight, your vision sight. But if you say, "Oh, look, it goes in that building," you have now made an inference, and if you walk over to that building, you'll quickly find out with an additional fact you were wrong. So be careful on your inferences. Be very careful. Be as quantitative as possible. Use instruments. Extend your observations with instruments. Vary the perspective. And then last, impose change. Okay, we will stop there with our first little lesson called observing.